So this is where we left off in 5.8. We can practice more problems. Again, big advantage to set the equation equal to 0. And I'm going to do that by adding tangent to the left side, subtracting 2 to the left side. And just think about factors of 2 that add to be 1. It would be 2 minus 1. So, it does take practice. So don't think that you can't figure it out just by looking at it. Or if you need to change tangent to be x, so x squared plus x minus 2. And then, I guess, go back and replace tangent for x. Now, some of these answers, because now you can identify that tangent of theta must equal negative 2, or tangent of theta is equal to 1. Because tangent of theta equals 1 is on the unit circle. Because if you think about sine over cosine being the same value, I said that wrong, but I think you get what I mean. Since tangent sine over cosine, if sine and cosine are the same value, when you divide, you'll get it equal to 1. Well, that happens at pi over 4 radians. And then again, in the third quadrant, at 5 pi over 4 radians. Now, this piece is not on the unit circle. So that's where you would want to go to your calculator, double check that you're in radians, because the direction is said to be in radians, and hit inverse tangent, second tangent of, I already forgot the number, negative 2. And you'll get that answer, but there's another issue, because that's a clockwise. That is not bigger than 0. I mean, directions, you want to be bigger than 0 but smaller than 2 pi. So let's think about what that means. We go this way. So to get it, that's going clockwise. So to fix our answer, you can add pi to it to get the negative answer in the second quadrant. So back to your calculator, add pi to that answer, bigger than 0, smaller than 2 pi, 2.034, and then add one more pi to get the fourth quadrant answer, 5.176. 2.034. I think I'll just show you the answer key on that one. So it's okay that sometimes you might need to use a calculator, if it's not on the unit circle. But if it is on the unit circle, then go ahead and figure out the exact value without really making any mistakes. All right. Just a few more problems, and you have to think outside of the box on a few of these. Okay, you might not get it right away. So on this problem, this looks complicated, and I only know because you can read the directions that it's telling you to use a double angle formula. It also gives you the hint that some are different, but that one doesn't look like a some are difference. It might be to your benefit to realize that that is the same as 2 times 2 sine theta cosine of theta. So then as you go back to your formula sheet, I'm leaving that right side alone. This piece, let me just underline it real quick. I meant to highlight and underline it. That piece, if you look on your formula sheet, is the same as sine of 2 theta. So it's still 2 sine of 2 theta is equal to negative root 2. Well, now what I would do is divide this 2 over. I could have said that at the beginning, just divide 2 over, and a lot of you would sit there and say, well, why did you only divide 2 over? And this is, the game changer, I guess, so to speak. So remember, and you might need to go back to a previous video to think about, we need 2 revolutions because of that number. So where does sine equal negative root 2 over 2? It happens in the third quadrant. So let me write 2 theta down first. That would be at 5 pi over 4 if you think of the reference angle. It also happens in the fourth quadrant, which is 7 pi over 4. But you also want to do 2 revolutions. So imagine if you started at 2 pi over 4, that would be at 8 pi over 4, and then added that 5 pi over 4 to it. You would have 13 pi over 4. And then another, adding 2 pi to that, you would have 15 pi over 4. Now, why do we have to do 2 revolutions? Is because we're going to divide everything by 2. Now, there's 2 ways of thinking of this to solve for theta. I prefer, instead of telling everybody to divide by 2, dividing by 2, and this is a Common Core standard, is the same thing as multiplying by 1/2. The reason why I say that is it makes more sense then to students that if you're multiplying by 1/2, dividing by 2 is just sticking that number to the denominator, and 4 times 2 is 8. 7 pi over 8. You have to do it for all of these because we're multiplying by 1/2 on all of these. So all of your answers that are bigger than 0 but smaller than 2 pi, because all of these are smaller than 2 pi, are shown right there. Again, if you're not quite getting it, feel free to use, to write down your questions or pause your video, go back to it. I'm going to try my best not to be offended, when you have questions. As I look at the next one, I don't know where your head would be at, but I would do 2 things at once. First of all, I would factor out a 2, and then I would notice that that's cosine squared of x minus sine squared of x. I'll leave that root 3 alone. And the reason why I mentioned that is because this is a double angle formula for cosine. This is the same as cosine of 2x, what's in parentheses, and I would also divide that 2 over. So using the same logic then, well, where does cosine equal root 3 over 2? That's right here at pi over 6 radians. But then it does happen again in the 4th quadrant, which is 11 pi over 6 radians. But don't forget that we need to do 2 revolutions, because we're going to be dividing by 2, so we have to do 2 revolutions to, once we multiply everything by 1/2, to get it back into 1 revolution of 0 to 2 pi. So that happens again at 13 pi over 6. Just think about if you add 2 pi to pi over 6. That should make sense. If you add 2 pi to 11 pi over 6, that should be 23 pi over 6, if I did my math right. So right now we are outside of the 2 pi threshold, but when we divide everything by 2 or multiply by 1/2, we're just going to stick a 2 into the denominator. So it makes the answers pi over 12. 6 times 2 is 12. 11 pi over 12. Again, if you are having issues, please write down your questions or rewatch the video. Maybe I said something in passing that made more sense then. One more thing I should mention, probably before you get to the homework, which is on the next slide, is if you ever factor something, I saw it in a previous video, it was the factoring one, something like this problem. Let me highlight it for a second. This problem right here. If I were to make this an equation and set that equal to 0, I want to bring this to your attention. Because I have a feeling that somebody might do this. So I'll go back to this for a second. If I set that equal to 0, some of you would look at that and say, okay, well, sine of theta is equal to 5 or negative 3. But if you look in the unit circle, the highest that sine ever gets up to is 1. And the lowest sine ever gets down to is negative 1. So it is possible that you factor things, you get to an equation, but then theta is impossible. There's no such values for theta that will make this equation true. Now, when we did that with tangent actually doesn't matter because you can have tangents that are bigger than 1 or smaller than negative 1. So I did want to bring that to your attention, and I did a bad job of your notes because I didn't include that in there. And I believe this homework is very long as well because you have 2 free responses, 1, 2, and all the way to number 12. So one more thing is number 12. I fully anticipate you using a graphing calculator to graph these types of problems. Okay, I do not expect you to do the graphs yet. All right, so good luck.